12th is our deadline for dropping this class, which I'm pretty sure is next week. I don't know if we're gonna have our other unit tests by then, so we're just gonna have to kind of play it by ear and see. Hopefully we will. I'm hoping to have our other unit test, but I don't know. I don't want to push it and make you go take it too fast.
About that diving thing,
Yeah.
at the finding that, I ended up finding out we would get an unofficial transcript from IB Tech, but we had them have a login and stuff, and he never really got that. So
Um.
he's expecting us to send me login information.
Oh.
So I
Yeah.
don't know if like we have that information.
I don't know. I don't have it, but I'll ask about it.
Like I have mine now, so just like
Right.
for when everybody else has to.
Right, because to get a transcript, what you're all going to need, if you get credit for this, is you're going to have to get a transcript from Ivy Tech that takes to the college that you're going to. If you're going to Ivy Tech, then I don't think you'll have to do it because they can just look it up. But if you get credit for this class, you have to get a you have to get a transcript or request a transcript. Apparently, you have to have a login to do that. And you have to pay like $8 or something. Usually, you have to pay to do it because it was unofficial when you did it. But to get an official one, you have to pay. That's what they get you for it because it's a free class, but then they make you pay $8 for the transcript.
You have to like request it online through like my class.
Yeah.
Something.
I'll find out about it. The math guy is going to come and observe our class Friday, I think, because he has to come and observe and make sure I'm teaching correctly. April 12th is next Saturday. April 12th is next Saturday? It's the following Saturday. So yeah, so we have this week and next week. I don't know if it's going to happen, so we might just have to wing it and people decide from there. There's not a whole lot left in this chapter, but then we have to review, so that's what I'm worried about. Getting our unit test in. But properties of logarithms, this is why I got so confused last week when I was doing a lesson to empty classroom. Because normally in pre-calculus, we learn the properties before we learn solve equations, and then I was trying to teach you how to solve much harder equations that we'll do after this section. So I was just a little confused. Mostly because I don't spend enough time preparing for this class, I think. I just try to wing it and use old notes and not have to rewrite everything is really the confession I have to make. I'm okay saying it. Because I teach all this in Algebra 2 when I used to teach Algebra 2. I teach all this in pre-calculus, so I just feel like I don't need to reinvent all my notes. I should just be able to pick and choose, but sometimes I mess up a little bit. We've talked about this one already. If you take log A of A, it's like saying A to the what power equals A, like that's always going to equal 1. ln is log base E, so it's like saying log E of E, that's also going to equal 1. That comes in handy when you're solving an equation and you're trying to get stuff to cancel out. Same idea with this. If you have an exponential and you raise it to a log power, again, I think we wrote this out before break, but it's been a long break. So maybe you've forgotten, but A to log A, since those are both the same base, that's just going to give you M. And the same thing on this one. E to the ln of M, E and ln cancel each other out, and you get M back as well. I actually made these notes before break, so I have no idea how many slides there are. That's exciting. Yeah, what? I haven't looked at this since the Thursday before break. That's when I did these, the Thursday before break. You awake over there, Rachel? You look a little tired. Did you stay up to 1 o'clock doing calculus? Because I'm the meanest teacher in the world if I gave you a worksheet of homework from here and I made her take a calculus test home, a whole giant AP calculus test. Log A to the R, the A's cancel out. Like the whole log A of A to the R cancel out, and you just get R back. And the same thing here, you just get R back. Why is that true? Because logs and exponential functions are inverses of each other. So the idea is when we solve equations, if you can get something like this, then you can cancel out some stuff. The other properties are ones that involve addition, multiplication, and exponent stuff. Because remember that a logarithm is really just an exponent, so the exponent rules kind of apply here, and that's the stuff that probably maybe we don't remember. So here we go. I have these written for logarithms and natural logarithms. A natural logarithm is still just a logarithm. talked about in the second hour today of your proof on your worksheet, or your quiz on Friday, where you just multiply the other side by that. It's true. I'm not happy about it. I said I think I'm gonna have to make a new rule on the. You did. I wasn't happy about it. But then Mason said, "Can't you really do that on any proof?" And so now I'm very.
Well, you really can't because.
If it equals 1.
Yeah, it equals 1. That's why I thought, like, alright, basically, there's one that had like 2 like fractions on it, and it said equals 1. You have to make equal that. I was like, wait. And I asked her, sometimes you just multiply right there. So I multiplied 1 by the entire thing.
And then he wrote, "You said I could multiply by anything." And I had to give him points, even though I felt like it was just wrong. It was just cheatingly. But they were super excited for you in the second hour. All right, so remember that a logarithm is an exponent. And when you multiply exponents, you add them. So that's where this rule comes from. If you have a log of something multiplied together, that's the same as saying log A of u plus log A of v. And for me, how do I remember these? I remember the rules of exponents. When you multiply exponents, you add them. So when you have a logarithm of multiplication, you can just break that up as addition. And the same thing works for ln. That's why I don't know if you want to write this twice or not. Ln of u times v is ln of u plus ln of v. And you got to make sure you make your u's look different than v's, or you're going to get all confused, right? So messy handwriters might have some trouble. Trevor, Bryce, Scott. We just did u's and v's in pre-cal today, and I said, sometimes people complain about my u's and v's, but maybe you should just write neither. Pretzel. Austin Pretzel. You can change them to x's and y's, I guess, if you want. When you divide exponents, what do you do with them? You subtract them. So if you have log of division, then you can break that up as subtraction. So that's log A of u minus log A of v, or ln of u minus ln of v. And really, sometimes we're going to break these apart, but when solving equations, a lot of times we go backwards with this. Like if they give you something like this, you want to be able to put it back together as division, because then you could just e both sides or something. And then the last one, a little bit maybe trickier to think about. With an exponent to an exponent, you multiply those. So if you have a log taken to an exponent, you can just pull that exponent out front and make it a multiplication problem. So that's the same as saying n times the log A of u, or pull that in out front, n times ln of u. And that becomes from the fact that when you multiply, or an exponent to an exponent, you multiply. And maybe you remember that. I don't know. Maybe not. Today's Nathan's birthday. He got to come back to school on his birthday.
My birthday's on Sunday.
You're 19? Man, you are old. I didn't turn 18 until July after I graduated. Like I graduated in May and didn't turn 18 until July. I was a young kid. So basically today we're just going to practice using these properties so that we can solve equations with them eventually. So write each logarithm as the sum or difference of logs, express powers as factors. That means simplify what you can, and it's just to kind of practice using these properties. I could do a full screen so we could know how many pages are left. Maybe after this. I'm not a big full screen fan. This guy always teaches in full screen. You know what I mean by full screen?
I think it's kind of odd that you don't.
I don't like it. I like to have my tools up there. Now I don't have my tools. I just have this dumb little box over here.
I really don't like that, but that's bigger than what it normally is.
I know, but I don't like it. I like all my tools. First of all, when we see division, what do we know? Subtraction. So I could rewrite this property. Division goes to subtraction. You got to know that. From there, you have to see if you can simplify anything. Log 3 of x, we can't simplify that because we don't know what x is. But what about log 3 of 9? What's that asking us?
1 to the power of 9.
3 to the what gives you 9, and what's the answer to that? 2. So I think that's where we would take that extra step, and we would say that that's log 3 of x, and then minus 2. Now, be careful, because people like to make up their own rules with logarithms. This minus 2 is not with that x. Do not think you can put that back together as division, because that doesn't work. You have to have a log and a log here. So this is it. Like, that's your answer, log 3 of x, and then minus 2. So don't be making stuff up. Look how much room I have now that I do it this way. Gets right so much, many more problems. When we see multiplication, what can we break that up as? Addition. So we can write this as ln of x plus ln of e to the x. Notice when you separate them, you have to put log or ln in front of everything. Bryce, are you sleeping already back there? And then what about this? Can I do anything with the ln of e to the x? Ln of e cancels, so it's just x. Can I say that's ln of 2x? No, because this plus x is separated from this ln of x. Huh?
No, I'm doing really good now, though.
Whoa. See, I want to do this box when it gets in my way. Now, what if we go the other way? What if we want to write it as a single logarithm? That's where we have to go backwards. And my advice is deal with the numbers in front first before you start putting back together addition and subtraction. I'll give you a second to write this down. I forget that you don't have this right in front of you. What do we do with numbers in front? Where could they go back? It's the very last rule I gave you. It's an exponent. If you see a number in front, it can go back as an exponent. So you could write this as log 3 of u squared minus log 3 of b, because an exponent can be pulled out front. So if you see a number out front, put it back in. You can do this all in one step. By all means, you can do it all in one step. But deal with your numbers first. And then what does subtraction go back as? Division. And notice it says write as a single logarithm, which means your answer should only have log written one time. If you have it written more than once, it's a problem. Because here's what people do. Don't write this down. But here's what people do every year. They say log 3 of u squared divided by log 3 of b. That is not okay, because you can only write log one time. The logs don't become divided. The letters become divided. The answer should be log 3 of u squared divided by v. So my advice is, remember that you're writing it as one logarithm, so you should only write log one time. What about this one? What do you think we should do first? Put 2/3 back in as an exponent. So we get ln of 8 to the 2/3 power. Without using your calculator, do you know how to evaluate 8 to the 2/3 power? The one on the bottom is your root, the one on the top is your exponent. So this is the same as saying like the cube root of 8 all squared. The bottom number is your root, the top number is your power. So what is the cube root of 8? 2, and what is 2 squared? 4. So that's really the same as saying ln of 4. You can type that in on your calculator. You're allowed to use calculators. So you can just type in 8 and then the caret 2 divided by 3, and it should give you 4. but I just like to show you, in case someday you don't have a calculator. And what do we do with subtraction again? Division. One time you write ln. It would be 4 divided by x squared plus 1. How do you feel about that? Overjoyed? 2 more pages before we get to the homework.
I don't really like the big page because I like when I can see the time right there.
And now there's no time.
Yeah.
I don't like the big page either. And it just seems so tall.
It really looks funny on your board.
Oh, I think I forgot to write something on here. I'm like the worst teacher ever in this class, just so you know. Can't wait for the guy from IUDEC to come and see how it's going.
Well, you actually playing for less.
What?
You actually playing for less.
Is that the right problem?
See, that's my problem. I just forgot to tell you some other stuff, I think. Do not use a calculator. What section is this? What?
6
What the heck was I doing here?
When did you make these?
Thursday. All right. I think we can do this. Let's see.
Why don't you just
I.
division?
Oh yeah. See, look, we can do that. This would be 18. Oh look, we can do this. I'm just kidding. I thought this was one where they give you ln of 2 and ln of 3, and then you have to rewrite them using ln of 2 and ln of 3, but that's not right. This is all you have to do. It's way simpler than I was making it out to be.
So wait a minute. Is that what it will be?
It'll be this.
You just wrote
Well, not this exact problem, but we could put subtraction as division, and what is 18 divided by 3? Oh my goodness. What's the log 6 of 6? Just kidding. We can do that. I was thinking it was crazy stuff. Because it's the 5 and that's all to the power. Like it's 5 and then that's the exponent. You did?
This guy made for me.
Oh. Did you give him money for doing that?
Yeah. And apparently I'm didn't give him any, but he had to try and take a picture of him. And then he started going on his mic and he said, white guy in the back, trans people.
Alright, you gotta be careful on these because you want to just cancel stuff out. But you can't cancel out 5 log 5 unless it's just one log up there. So step 1, can we put that together as one log? What would you do? How do you put addition back together? Multiplication. So that would be 6 times 7 is 42. Yeah? Yeah. And then what can you do of 5 log 5? It cancels. These are the same base, which means what's the answer here? 42. I forgot how much I like these problems.
One more page.
One more page.
This last page is going to be brutal. So
Yeah.
don't hurry those.
It was a trick. It was a trick.
Yay!
What a brutal page.
You're from here now.
Horrible. It's horrible.
The back one he would have said that when he said that.
14 through 28 even is like what we just did, like the simplifying part. And then 37 through 44, those are breaking it up using the properties, and 57 through 60 are a little bit harder ones of those. And we'll see how that goes, and we'll do some more difficult ones tomorrow. But not so bad. And you have like 15 minutes to work. That's ridiculous.
No, it's 12, but
13. Focus, focus.